Hey, Mark. Mark, you unmute your mic.
Hey, David.
There you go. Okay, cool. I got your paper here. Let's just dive in.
All right.
Tell me the opposite side and the adjacent side to theta.
So we have
Opposite. Yeah, not yet. Just tell me what the opposite side of theta is.
that'd be the adjacent A.
Okay. What's the adjacent side of theta?
A.
No. A is the opposite. B or C are the adjacent sides. In other words, the adjacent side means what makes up the triangle, or angle rather. Okay? Now, the problem with this question is he didn't really state it properly. It has to be a right triangle. Because A over B is not the tangent of theta. It's only in a right triangle, where if I have theta, that's the opposite, that's the adjacent. When you have a right triangle and they say adjacent, they always mean the adjacent side that is not the hypotenuse. Because C is still adjacent to theta, but it's the hypotenuse, so we never choose the hypotenuse. So what do we have if we have an opposite and an adjacent? Now you need SOHCAHTOA.
Yeah.
Which one applies? If I have just A, just B. What? There's my opposite and my adjacent.
Would that be tangent?
Yeah, it's got to be tangent. Because with sine, I need an opposite and a hypotenuse. With cosine, I need an adjacent and a hypotenuse. So the only one that involves opposite and adjacent is tangent. But again, that only applies in right triangles. It is not true in this triangle that I drew. And nowhere here does he say it's a right triangle, but he means it. So I can't criticize a geometry teacher that tries to have a sense of humor, at least. I'm being a little facetious. I do like teachers to have a sense of humor, but it would be a little bit better if it was funny, actually. Huh? Okay. Number 2.
Would that be side?
Yep, because you have an opposite and a hypotenuse. And number 3.
That's cosine, correct?
Yeah. In fact, the only thing you need on this problem is to know SOHCAHTOA, and you'll get it right. Tells you all 3 of them. All 3 questions are the second 2 letters of each of these. So as long as you know the S, the C, and the T stand for sine, cosine, and tangent, you got it made with these 3 questions. All right. I don't suppose you know how to eliminate this icon right there?
I don't.
It's constantly covering up my questions, and I don't want it there. It does me no good. So I haven't figured out how to get rid of it, though. I thought maybe you might know.
Could you drag it?
Well, let me try. Nah.
No.
In fact, attempting to makes my whole thing kind of go nuts, and until I click on the whole thing to stabilize it. All right. You got your calculator?
I do.
Make sure you can do cosine of 11 degrees. Round it off to 4 decimal places. Round the angles off to the tenths place. So what's the cosine of 11?
The calculator's still booting up.
What kind is it? Is it a TI Inspire or
Yeah.
P4?
CX.
C Inspire?
Yeah.
Okay. Most important thing you have to be careful about is making sure that you're in degree mode if you want to be, or radians mode if you want to be. Now, all these questions appear to be in degree mode, but I don't know if you can count on that. And the one bad thing about that calculator you're using is it doesn't really make it clear which mode you're in. In fact, it's very difficult. You have to know that calculator really well in order to change modes. But I suspect that you've always been in degree mode and you have never put it into radian mode. So
Yeah.
you're probably fine. What's cosine of 11?
So
If you had,
I can put in, I forgot how to put in a cosine. How do I go about doing that?
look for the trig key. You have an Inspire for sure?
Yeah, I have the TI Inspire CX.
Okay. There's a trig key on there, on the left side of that calculator.
Oh, there it is.
Okay. Hit trig.
So I got 11.
And now it actually lets you choose any of the 6 trig functions or any of the 6 inverse trig functions. So you're going to use that key for all 6 of these questions. Now, what I'd like you to do is give me your rounded off answer, because I'm going to do it in mine.
So I got 0.9816.
Hold on.
For the cosine of 11.
Okay, round it off.
Well, it goes longer than that, but...
Yeah, but the directions say round it off to 4 decimal places.
Yeah, 0.9816.
Oh, okay, sorry. Tangent of 59.
Okay, let's go. That would be... Wait, how do I tell if I'm solving for a angle or a...
Just put that number inside the parentheses. In other words, the moment you hit trig and tangent, it puts up a tangent with 2, a left paren and a right paren. Whatever number you type will go inside the parentheses. And you don't put degrees. Just type tangent 59.
So I got 1.6643.
Okay, good. And then do sine of 38.
0.616. 6157.
Okay, good. And solve for angle A in number 4.
Would that be 12.20? 12.2?
What are the directions? Round angles off to the place. 12.2.
Yeah.
When they say the tenths, they mean 1 decimal. If they said the tens place, you'd have rounded it off to 10 degrees, right? So there's a difference between the tens place and the tenths place. The tenths place means rounded off to 1 decimal.
Okay.
Okay, and do inverse cosine.
Yeah, I got 84.3.
Hold on, sorry. I'm lagging you. Okay, and finally tan, inverse tan of that other number.
0.1.
Okay. Take the inverse tan of, take the inverse sine of 1.1.
I got 0.019197.
Really? Shouldn't have gotten that. Inverse sine
Oh, sorry.
of 1.1.
It's undefined.
Yeah, because the sine can never equal anything number greater than 1 or any number less than minus 1. If you look at a sine curve, it always goes between 1 and minus 1. Never above the 1, never below the minus 1. So when I ask you to find the angle where the sine was equal to 1.1, it doesn't exist. It's impossible. It's undefined.
Okay.
What's the law of sines?
I don't quite remember.
The law of sines is the easy one. The sine of the angle over its opposite side is a constant in any triangle. In other words, if I have a triangle, not a right triangle, and I'm going to label it A, B, C, opposite the capital A is side little a, side little c, side little b. Now, what I can say is the sine of A divided by little a is the same as the sine of B divided by little b. And it's the same as the sine of C divided by little c. So it's as easy as they get in terms of formulas. And you don't even need sine on top. In other words, you could flip all 3 of these and you would still have the law of sines.
Okay.
Okay? Just remember that concept, that it's not the angle opposite side that's fixed, it's the sine of the angle divided by the opposite side that is a fixture in all triangles. Not triangle to a different triangle, but within the same triangle, this relationship holds true. Okay? Law of cosines. Easiest way to remember the law of cosines is to start out with the Pythagorean Theorem. So far, so good? Now, to subtract from that, 2AB cosine of capital C. And there's actually 3 laws of cosines. Let me write the others for you. What would you think A squared would be?
A squared equals B squared plus C squared minus 2BC cosine B?
No, it's always the cosine of whatever letter is over there.
Oh, A.
Okay. In other words, there's a pattern to all 3 of these. What's B squared equal?
B squared equals A plus C minus 2AC cosine B.
A squared plus C squared minus 2AC cosine B. And which one you use kind of depends on the drawing that you're looking at. They're all basically the same thing. merely says is that side C is always equal to that. And also notice that if angle C is 90 degrees, this whole part disappears because the cosine of 90 degrees is 0. And you would have the Pythagorean theorem. That's why I say start with it. Because even for a right triangle where the Pythagorean theorem holds, I could use the law of sines, or excuse me, the law of cosines. In other words, we know that in a right triangle, c squared is equal to a squared plus b squared. Well, in a right triangle, angle C is 90 degrees, and this goes to 0. So it's not a bad way to check it if you ever forget what it is knowing the Pythagorean theorem. It's basically a modification of the Pythagorean theorem.
Okay.
Okay. Hold on a second. I think I have to go that way to, oh no, right. Just realized what was going on. Okay. In your calculator again. Well, first of all, what equation is going to let you solve for A in number 1? Always start with the angle and figure out the trig function of that angle. So what do you have in your backpack here?
What do you mean?
You have an opposite and an adjacent, correct?
Yes.
So what's the equation?
Tangent.
Tangent of has to be an angle. Always. Yeah. In other words, we take trig functions of angles. We take inverse trig functions of ratios. This trig function produces what ratio?
0.5317.
Start off 10 divided by A. That's what the tangent
Oh,
of
that's 5.3.
And then you solve for A. In other words, you got A
Yeah, 5.3
divided by 10 of 28.
Yeah.
Okay. And you rounded it off to the 100th place. What does that mean? How many decimals?
That's 2.
Correct. And still they want you to round off angles to the 10th. Okay, on number 2, what equation can I write? Starting with the trig function and the angle on the left.
So we have another opposite and another adjacent.
B is not adjacent. We have an opposite and we have a hypotenuse.
Okay. 1 second. We have.
Give me the equation. I don't.
Is that sine?
Yeah. In other words, you can always
Sine of 49.
TOA, and if you know you have an opposite and a hypotenuse, it's got to be that one. So it's the sine of what?
49.
Equals?
31 divided by the sine of 49.
No. Well, okay. Start with that. Okay. And then solve for B. Okay. So first you have to multiply both sides by B, and then you have to divide both sides by sine of 49. And then that number you can get out of your calculator. Let's go on to at least solving for an angle. So in 3, regarding this angle right here, C, which trig function relates these two sides?
That's cosine.
Correct. So what's the equation?
Inverse cosine of 18 over 21 equals c.
Good. What do you get?
31.
Rounded to the 10th place?
Yeah, 31.00.
No, excuse me. Okay. Area.
Okay.
There's an area equation. In other words, the area of a triangle is 1/2 base times height. But we don't know what the height is here because it's vertical height.
Okay.
But there is a formula for the area of the triangle based on sides and angles. You know what it is?
No.
You know, unfortunately, I have a bad habit of forgetting this one also. Why is that hard to remember? Let me think for a moment. Has to do with the sine of 70. I think here's what it is. 1/2 of, of the two sides and the angle that don't make up those two sides. In other words, I think it's the following. It is 1/2 of 14 times 20 times the sine of 70. And before I go with that, I need to check it. Make sure that I haven't given it to you wrong. It's going to tell me right here. No, it isn't. Wow, hold on. How did I get in this chapter? Here we go. You don't have it at the back of the chapter. Amazing. Hold on. You never know where it is either. Just a second. This is actually a pretty important one. I don't know why I have trouble memorizing it. It's not a right triangle. I don't think it's in my geometry book. How come they're asking you this? Now I know. I think. No. You shouldn't be having this question. And it's not taught in geometry, and that's why I can't find it in my geometry book. Yeah, why are they giving you this question? One second. I have to look in my pre-calc book to come up with it. Let's see. Can I figure this out? Yes, if that angle was 90 degrees, the sine of 90 degrees is 1, the base would be 20, and the height would be 14. So it is what I've put up there. It's 1/2 of the two sides that make up that angle. See how the angle of 70 degrees is made up of 14 and 20. And
Yeah.
perhaps the way to memorize it is to think, well, what if the triangle was a right triangle, and this was 14, and that was 20? Well, now we know what 1/2 base times height is. It's that. And if that angle was a right angle, sine of 90 degrees would be 1, and it would work perfect. So by deduction, that has to be the right equation. And yeah, we'll leave it at that. I still don't know why exactly you're getting that problem, but that is an isosceles triangle. You could drop a vertical, but we wouldn't know how long that vertical was. Would we?
Yeah.
Actually, we'd be able to figure it out from the Pythagorean Theorem, because then we'd have a 720. We'd figure out that short side. So we could do it without this trig formula. But it would involve the Pythagorean Theorem. All right, Mark, hopefully that is a good review of trig for you. Obviously, SOHCAHTOA is the most important thing to memorize. Make sure you know it by heart. Know what each letter means. Okay? Let's see, what's our schedule look like here? You got your final coming up. Have we talked about your schedule for your final? Let's see.
We have another thing for tomorrow, too, I thought.
We do. We have a 4:30 tomorrow, and we have a 4:30 on Tuesday, and that's all we have next. Oh, no, and then I got you down for Thursday, but you probably don't need that one, do you?
I don't think I do.
Yeah, so let me take that away, because your final's before Thursday, right?
Yeah.
Okay. I'll have openings if you need that. I'm going to be very, very busy.
Okay.
Monday, Tuesday, and probably Wednesday, but by Thursday I'll be opening up. So, all right, Mark, I will talk to you on Monday.
All right, thanks.
Bye-bye.